This is the video for section 4.4 notes, slides 20 through 22. All right, so in 4.4, we're talking about the second derivative and how it plays a role in the function f. So if a second derivative is positive, a curve looks like this. All right, if a second derivative is negative, a curve looks like this. All right, so what I want you to think about is what's going on with f prime. Well, I say here f prime is increasing, but let's make sure we understand. So I'm going to highlight a few points here along this curve. All right, so I want to think about f prime. F prime is the slope of the tangent. So as I move to the right, what's going on with the slope of the tangent? Well, let's actually put some numbers in here. This is negative number. So let's say I don't know, negative 3. All right, as I go to the right, the slope gets less negative, or it gets less steep. So maybe like -1, then this is 0, then maybe this is +1, this is +3. So what's going on with these numbers? -3, -1, 0, 1, 3, they are increasing. So f is increasing. Sorry, f prime is increasing. All right, second derivative negative looks like this. So what does that mean? Well, that means, once again, if I think about f prime here, let's say this is +3, +1, 0, -1, -3, f prime is decreasing now. All right, and so we want to make sure we understand that when I'm looking at f, remember this is a graph of f, right? This is a graph of f. That f prime is increasing means that f double prime is positive, right? f prime decreasing means f double prime is negative. All right, so now it's important to remember that yes, f prime is increasing, but it could be that f prime is negative, and at certain parts f prime is positive, and at certain parts f prime is 0. Okay, so here f prime is decreasing, but it could mean that f prime is positive, then 0, then negative, right? I mean, so you have to remember that it doesn't mean that f prime is positive. It means that f prime is decreasing. So it's very important that you pay attention to that. All right, so that's slide 20. All right, so slide 21. All right, f is concave up. Okay, so that's a new term. On A to B, if and only if the slopes of the tangents to f are increasing. So what does that mean? That means that f prime is increasing, or which we say is that f double prime is positive. So f is concave up when f prime is increasing, which means that f double prime is positive. F is concave down on A to B if and only if the slopes of the tangents to f are decreasing, which means f prime is decreasing, or which means f double prime is less than 0. So remember, concave up means f prime is increasing, which means that f double prime is greater than 0. Concave down means f prime is decreasing, which means f double prime is less than 0. All right, so let's say I have a picture that looks like this, okay? And I'm going to highlight some points here. All right, so let's say that this is A, B, C, D, and E. All right, so what's going on this graph? Well, from A to B, what can you say? You can say that f prime is positive, but f double prime is negative, right? Meaning it is concave down, okay? What's going on from B to C? Okay, B to C, f prime now is negative, and f double prime is also negative, right? It's still concave down, okay? C to D, you can say, well, once again, f prime is still negative, right? Because it's still decreasing, and f double prime now is positive because now this curve is concave up. All right, and then from D to E, f prime is now positive, right? Because this function is increasing, and f double prime is positive because this curve is concave up. So C is a special point, right? Why is this a special point? Because this is where the concave down curve changes to concave up. All right, so that's slide 21. All right, so on to slide number 22. All right, it says use the following functions to determine the intervals for which f is concave up and concave down. So what do I want to know? Well, concave up means that f double prime is positive. Concave down means f double prime is negative. So what do I need to do? Well, I basically need to do a sign analysis on f double prime. So that means I need to find f prime. So f prime of x. So that would be 3x squared minus 1. And then I need to find f double prime. All right, so what is the derivative of 3x squared minus 1? That would be 6x plus 0. So now, in order to know when f double prime is positive or negative, I first of all need to know when f double prime is 0. So I set 6x equal to 0, and so I get that x equals 0. So x equals 0 goes on the number line, and we're going to analyze f double prime. So 0 goes here, and I have 6x on the side. Now, 6x is 0 at 0. So now, pick a number to the left of 0. How about a negative number? Well, of course, 6x is negative. To the right, like positive. And so what can you say? The second derivative would be negative to the left of 0. So you would write that f is concave down on the interval negative infinity to 0. F is concave up when f double prime is positive. So that would be from 0 to positive infinity. Okay. Now, just to make sure we understand, f of x is x cubed minus x. If I were to graph x cubed minus x, it actually looks like this. Okay, so notice it's concave down over here from negative infinity to 0 and concave up from 0 to positive infinity. All right, so that is a little bit about concavity. All right, so then continuing on slide 22, number 2, f prime, notice we're given f prime, is 3x plus 2 times x minus 3 squared. And so I want to find f double prime of x. All right, so I'm going to use the product rule. 3x plus 2 times the derivative of x minus 3 squared, which would be 2 times x minus 3 to the first, times the derivative of x minus 3, which is 1. And then plus, second part of the product rule, x minus 3 squared times the derivative of 3x plus 2, which is just 3. So now I want to set this equal to 0 and solve. So I have two terms here. So I'm going to factor out whatever I can. So I can factor out in x minus 3 to the first, and that's actually it. So that would leave me with 2 times 3x plus 2 plus a 3 times x minus 3. All right, and so that means I'm going to set x minus 3 equal to 0, and then I'm going to set this thing equal to 0. So I'm going to distribute here 6x plus 4 plus 3x minus 9 equals 0. All right, so x minus 3 equals 0. That means x equals 3. And over here, 6x minus 4 plus 3x minus 9, that becomes 9x minus 5 equals 0. So x equals 5/9. All right, so now I'm going to set up my number line here. All right, so on the number line goes 5/9 and 3. All right, so now on the side here, I'm going to put x minus 3, and I'm going to put 9x minus 5. So I have two rows, top row 0 above 3, bottom row 0 above 5/9. All right, pick a number to the left of 3. How about 0? 0 minus 3 is negative. Pick a number to the right, like 4. 4 minus 3 is positive. All right, number to the left of 5/9, like 0. 9 times 0 minus 5 is negative. Number to the right of 5/9, like 1. 9 times 1 is 9 minus 5 is positive. All right, and so the second derivative is going to be a negative times a negative, which is positive, negative times a positive, which is negative, and a positive times a positive, which is positive. So what can we say? F is concave up when this thing is positive. So that would be from negative infinity to 5/9 and from 3 to infinity. All right, and then we can say f is concave down on the interval 5/9 to 3. So that is finding when f is concave up and concave down.